Imagine stepping onto a shoreline at low tide and finding what appears to be a vast floor of rectangular stone tiles. The lines meet too cleanly, the blocks repeat too regularly. Yet no mason laid a single one. Now travel to Wyoming, where a tower of rock rises 264 meters above its base. Its sides are divided into immense vertical columns, some more than 2 meters across, as if an unknown civilization bundled skyscraper-sized stone beams together and planted them in the earth, then leave the ground entirely. From orbit, astronauts see a circular target in the Sahara nearly 40 kilometers wide. Ring surrounds ring with such precision that it was once mistaken for an impact crater. It looks less like a landscape than a symbol drawn across a continent. These are not ruins, monuments, or abandoned machines. They are natural formations produced by cooling magma, dissolving limestone, fractured sandstone, freezing water, wind, chemistry, and time. That understanding the mechanism does not make the result look any less impossible. Today we are counting down 15 rock formations on Earth that look artificial but are not. Each one has a measurable geological explanation, and number 1 is so enormous that its true design can barely be recognized from the ground. Before we begin, tell us which of these places you would most want to see with your own eyes. Number 15. The Tessellated Pavement, Tasmania, Australia. At Eaglehawk Neck on Tasmania's southeast coast, the ocean withdraws to reveal something that resembles the foundation of a vanished building. A flat platform of siltstone has been divided into rectangles, squares, and long straight lanes. From above, it could be mistaken for paving designed by surveyors. Up close, the cracks seem to form deliberate joints between individual slabs. The pattern begins with natural fractures. The Permian-age sedimentary rock was stressed and split along several intersecting joint sets. Those fractures did not shift the stone like faults. Instead, they created lines of weakness crossing one another at angles that produced the tiled geometry. The sea then became the sculptor. On parts of the platform that dry for longer periods, salt water settles into the rock and evaporates. Growing salt crystals attack the centers of the blocks, creating shallow depressions known as pans. Closer to the water, waves and sand work more aggressively inside the joints, lowering the cracks and leaving the centers raised like loaves of bread. The result is 2 versions of the same apparent pavement. One looks like rows of trays pressed into the shore. The other looks like blocks placed side by side. The pattern changes as tides move across it, and the wet stone reflects the sky like polished flooring. Nothing here required measurement, cutting, or construction. The grid was already contained in the direction of the fractures. Salt, waves, and abrasion simply made it visible. It is a reminder that a straight line in nature is not evidence of a human hand. Sometimes it is only a crack that has been waiting thousands of years for the ocean to reveal it. Number 14. The Chocolate Hills, Bohol, Philippines. Across the center of Bohol, hundreds upon hundreds of smooth cones rise from the tropical landscape. From a viewing platform, they appear to repeat toward the horizon with the consistency of an enormous planned development. Their slopes are similarly curved. Their summits are similarly rounded. During the dry season, the grass turns brown, giving the formation its famous name. They are not burial mounds or artificial earthworks. They are a cone-karst landscape made largely from limestone that began as material associated with ancient coral reefs. UNESCO describes the underlying story as a record of reefs that flourished during the Pliocene, roughly 2 to 5 million years ago, before tectonic processes raised the terrain and erosion began reshaping it. Rainwater absorbs carbon dioxide from the atmosphere and soil, becoming weakly acidic. Over long periods, it dissolves calcium carbonate along cracks and drainage paths. Instead of cutting the entire limestone surface down evenly, water isolates resistant masses. Valleys deepen between them while the remaining rock assumes rounded conical forms. The exact count depends on the boundary and survey method, which is one reason different totals circulate. What matters visually is the repetition. A broad field of near-matching hills created without a blueprint. Their similarity comes from common material, climate, fracture patterns, and drainage acting across the same landscape. The hills are also not frozen. Chemical weathering continues whenever rain enters the limestone. Vegetation slows some erosion and accelerates other processes through roots and soil chemistry. What looks like a completed installation is actually a living karst system, dissolving one drop at a time. Number 13. The Matobo Hills, Zimbabwe, south of Bulawayo, enormous granite boulders balance in arrangements that seem to ignore gravity, narrow points. Others form stacks, shelters, and walls that look assembled by giants. And a single push appears as if it should bring everything down, yet many of these compositions have survived far longer than any human structure. The Matobo Hills rise from an ancient granite foundation, and UNESCO describes a dense concentration of distinctive landforms produced because variations in the composition and alignment of the granite responded differently to millions of years of weathering. Water entered joints below and near the surface. Chemical alteration weakened corners and edges. As overlying material was removed, pressure decreased and sheets of rock separated from larger masses. Rounded blocks emerged through spheroidal weathering, a process that attacks exposed corners from several directions and gradually turns angular pieces into smooth boulders. Erosion then cleared away the softer decomposed material between them. And what remained were resistant cores positioned in the same places where the original granite had fractured. That explains why the rocks can look stacked even though no one lifted them. The apparent pile was revealed from a continuous body rather than constructed from loose pieces. Gravity has removed many unstable blocks, leaving arrangements that happen to find durable points of support. These hills also hold a human record. And rock shelters preserve paintings and archaeological evidence spanning long periods of occupation, and the formations remain culturally significant to local communities. And the landscape may be natural, but people have interpreted, inhabited, and remembered it for thousands of years. At Matobo, erosion did not merely carve stone. It edited a buried structure until only the most improbable-looking balances remained. Number 12. The fairy chimneys of Cappadocia, Turkey. In central Anatolia, valleys are filled with cones, towers, and capped pillars that resemble a city designed for beings much larger than humans. Some stand alone like factory chimneys, and others crowd together in pale ranks. Windows and doorways appear in many of them, which makes the entire landscape seem constructed. There is an important distinction. The formations themselves are natural, but people later carved chambers, churches, homes, and storage spaces into the soft rock. Human architecture occupies geology that already looked architectural. The story began with volcanic eruptions that spread ash fragments and hot flows across the region. These deposits hardened into layers of tuff and ignimbrite with different resistance to erosion. Water cut valleys into the plateau. Rain, runoff, wind, temperature changes, and gravity removed the weaker material. And where a harder cap protected softer rock beneath it, a narrow pillar survived while the surrounding slope retreated. That protective relationship gives many fairy chimneys their impossible proportions. A heavy-looking block sits on a thinner neck, almost like a roof placed on a tower. Once the cap breaks or falls, the exposed column erodes much faster. Scientific measurements of Cappadocian ignimbrites confirm that different stages of the landform can weather at very different rates. UNESCO notes that erosion continues to create and destroy pillars. This is not a permanent sculpture garden. It is a moving front between durable layers and fragile ones. And the human spaces make conservation even more difficult, because the same softness that allowed people to excavate elaborate interiors also makes those interiors vulnerable. Cappadocia looks artificial because geology provided the towers and humanity added the rooms. Nature built the skyline. People moved inside it. Number 11. Zhangye's colorful hills, Gansu, China. At the edge of the Kilian Mountains, broad ridges appear painted in stripes of red, orange, yellow, gray, and green. The bands curve across slopes like layers in a colossal piece of fabric. In strong evening light, the landscape can look digitally enhanced or deliberately colored. Some photographs do exaggerate the saturation, but the underlying bands are real. Zhangye UNESCO Global Geopark lies in a tectonically complex transition zone. Over immense spans of time, rivers, lakes, and other environments deposited layers containing different minerals and grain sizes. Iron-bearing minerals produced many of the red and ochre tones, while other materials contributed lighter and darker bands. Those sediments did not remain flat. Tectonic forces associated with the rising Kilian region folded, tilted, fractured, and uplifted them. Erosion then sliced through the deformed layers. The colors visible today are therefore not paint sitting on the surface. They are the exposed edges of rock beds extending into the hills. This is what makes Zhangye look designed. A painter creates stripes by adding color to a surface. Geology created these stripes by stacking material through time, bending the stack and cutting across it. The pattern is a cross-section of vanished environments. The term Dangsha is used for a family of landscapes associated with red beds and steep erosional forms, although Zhangye's colorful hills have their own local geological history. Their appearance changes with moisture, dust, sun angle, and camera processing. After rain, colors may deepen. At noon, they can flatten. Near sunset, shadows restore the relief and make each band appear to glow. The hills are not a mural, they are time arranged in layers then turned on edge. Number 10. Ischigualasto and Talampaya, Argentina. In the rain shadow of the Andes, cliffs rise like fortress walls and isolated rocks resemble machines, towers, mushrooms, and carefully shaped monuments. Ischigualasto is widely known as the Valley of the Moon because its pale and multicolored sediments create a landscape that feels detached from Earth. Nearby Talampaya contains red sandstone walls reaching roughly 200 meters in height. These forms are part of something even larger, a sedimentary basin preserving an extraordinary continental record of the Triassic period. UNESCO identifies 6 geological formations across the connected parks, documenting environments and vertebrate life from approximately 245 to 208 million years ago. Rivers, floodplains, lakes, volcanic ash, and changing climates deposited different layers. Later uplift exposed them. Wind and infrequent but powerful water flow exploited fractures and differences in hardness. Softer beds retreated, while more resistant material remained as caps, columns, and strange isolated bodies. At Ischigualasto, rounded concretions appear in places like stone balls scattered across a court. These shapes formed when minerals cemented sediment around internal centers before erosion released them from the softer surrounding rock. Their symmetry invites stories of carving, but their structure belongs to sedimentary chemistry. The apparent statues have no intended subjects. Human perception supplies submarines, sphinxes, mushrooms, and cathedrals because our brains search unfamiliar shapes for recognizable objects. Geologists read the same cliffs differently, as changing river channels, soils, ash layers, fossil beds, and episodes of burial. Here, the most important architecture is invisible. It is the sequence of strata that preserved one of Earth's great biological transitions, while erosion turned its outer surface into a gallery of accidental monuments. Number 9. The Lena Pillars, Sakha Republic, Russia. Along stretches of the Lena River, a stone wall rises from the Siberian forest and breaks into an army of towers. From a boat, the formation resembles a ruined city extending along the bank, buttresses, needles, gateways, and crowd silhouettes appearing one after another. The rock contains limestone, dolomite, marl, and other layers laid down in ancient Cambrian seas. The site is globally important, not only for its appearance but for its record of early animal diversification during the Cambrian explosion. UNESCO notes that it preserves major fossil evidence and exceptionally continuous carbonate sequences. Its skyline, however, was created much later. Water-penetrated vertical fractures, carbonate rock dissolved along those paths. In Siberia's extreme continental climate, repeated freezing and thawing widened cracks and detached fragments. Rivers, gravity, and surface weathering removed the debris. Permafrost and thermokarst processes added another layer of complexity. As the fracture network opened, continuous cliffs were divided into isolated pillars. The verticality makes the result look built, but the walls between the towers are simply the missing rock. Erosion created empty space and allowed the remaining stone to imitate architecture. The scale is difficult to absorb because the line of pillars continues beyond a single view. Their forms change as a vessel moves along the Lena. A spire becomes a face, then a castle, then a thin blade before disappearing behind the next projection. What remains under study is not whether the pillars are natural, but the detailed interaction of cold climate weathering, karst dissolution, rock structure, and landscape evolution. The broad mechanism is understood, the exact history is written across countless fractures. Number 8. The Ennedi Massif, Chad. In northeastern Chad, the Sahara contains stone bridges, mushrooms, towers, arches, and labyrinth spread across a sandstone massif larger than some countries. From a distance, cliffs resemble defensive walls. Up close, openings pass through rock with curves that could be mistaken for engineered spans. UNESCO describes a plateau sculpted by water and wind erosion into canyons, valleys, cliffs, natural arches, and pitons. The presence of water is especially important. Today's Sahara can make these forms seem like products of wind alone, but the landscape records wetter periods when runoff had far greater power. Water entered cracks, cut channels, undermined softer beds, and enlarged openings. Wind transported abrasive sand and cleared loose material, but it did not work as a simple stone-cutting machine. Temperature changes, gravity, chemical weathering, and the contrast between stronger and weaker sandstone layers all contributed. The famous arches are temporary solutions to an erosional problem. Rock remains across an opening because that span is strong enough for the moment. Eventually, fractures grow, blocks fall, and an arch becomes two separate towers. The form that looks most engineered is often the formation closest to structural failure. Ennedi also preserves thousands of rock paintings and engravings, evidence that humans experienced a different Sahara and repeatedly returned to these shelters. Permanent and seasonal water points still support wildlife and pastoral communities in an environment that appears nearly empty from space. This creates a powerful reversal. The formations are natural, while the images on their walls are human. The arches were not built as monuments, but people have used them as landmarks, shelter memory, and passage for millennia. Number 7. The Wave, Arizona, United States. Inside Coyote Butte's north, sandstone folds across the ground in red, cream, and orange ribbons. The lines sweep around bowls and rise along walls with the continuity of carved grooves. At certain angles, the rock resembles frozen liquid flowing through a carefully machined channel. The visual motion comes from cross-bedding. Long before the modern desert, wind moved dunes across a vast sandy environment. As each dune advanced, sand cascaded down its face and accumulated in inclined layers. New dunes buried older ones at different angles. Minerals later cemented the sand into Navajo sandstone, preserving the internal structure of those moving dunes. Uplift and erosion exposed the cross-sections. Wind, water, and the breakdown of the rock removed material along subtle differences in hardness. Thin bands became visible as parallel lines, while curved surfaces turned those lines into waves. The formation is exceptionally fragile. The Bureau of Land Management limits entry through a permit system, and visitors must prepare for heat, difficult navigation, unmarked terrain, and flash flood danger. That restricted access is not evidence of a secret. It is a response to concentrated foot traffic on a delicate wilderness surface. The wave looks carved because its bedding provides a visual guide to erosion. Each line allows the eye to follow the ancient slope of a dune through solid stone. What appears to be a sculptor's repeated chisel mark is actually a record of individual episodes of sand moving under Jurassic winds. The rock is not imitating water. It is preserving motion, and erosion has opened the book at exactly the right page. Number 6. Giant's Causeway, Northern Ireland. At the foot of the Antrim Cliffs, approximately 40,000 basalt columns descend toward the Atlantic. Their flat polygonal tops form steps, platforms, and pavements. Many have 6 sides. Together they resemble the remains of a bridge, which inspired stories of the giant Fionn mac Cumhaill building a route across the sea to Scotland. The scientific explanation is one of geology's most elegant demonstrations of order emerging from physics. Nearly 60 million years ago, lava spread across this region as the North Atlantic began to open. Thick pools of molten basalt cooled and contracted. Contraction created stress. Cracks formed at the cooling surface and propagated inward, tending to arrange themselves in networks that distribute stress efficiently. The result was a mass divided into polygonal columns. Hexagons are common, but the formation also contains columns with other numbers of sides. Nature did not measure each block. A repeating physical process produced the average order. The causeway is especially revealing because erosion exposes both vertical columns and their horizontal cross-sections. The main pavement turns a deep three-dimensional fracture network into a surface visitors can walk across. Elsewhere, tall columns stand in cliff faces like organ pipes. For centuries, this place sat at the center of debate about whether basalt formed from water or fire. Evidence from volcanic landscapes helped establish the igneous explanation and advance earth science. Today, the mystery is not who built the road. The more interesting question is how simple rules of cooling can produce geometry on such a scale. Giant's Causeway looks constructed because physical systems often organize themselves without a planner. Number 5. The Bungle Range, Pernululu, Australia. From the air, hundreds of rounded domes rise from the Kimberley like a field of enormous beehives. Each one is wrapped in alternating orange and dark bands. Their spacing, shape, and repeated striping make the massif look like a settlement and assembled from matching structures. The Bungle Range is made from ancient sandstone, and its present form developed through a complex interaction of geology, climate, erosion, and life. Australian heritage authorities describe towers rising as much as 50 meters of the surrounding savanna and a landscape carved over roughly 20 million years. The orange bands are exposed sandstone stained by iron compounds. The dark bands support microscopic cyanobacteria where moisture conditions are suitable. These organisms form thin crusts that help stabilize the fragile surface. The pattern therefore reflects small differences in grain size, permeability, water retention, and exposure. Water follows fractures and weaknesses, widening narrow passages into chasms and separating the plateau into towers. Rain can be seasonal, but when it arrives, it concentrates in channels with tremendous erosional effect. Wind and temperature changes assist, while the biological crust affects which surfaces resist breakdown. Although Aboriginal communities have known this country for an immense span of time, the range remained little known to the wider Australian public until the late 20th century. Its remote location still limits access, and much of the landscape is best understood from the air. Scientists understand the main processes, but UNESCO documentation notes that sandstone cone karst remains unusually complex. The domes are not simple piles of sediment. They are products of structure, water, weathering, and living films operating together. What looks like decorative paint is biology. What looks like a planned city is a plateau being dismantled. Number 4. Tsingy de Bemaraha, Madagascar. Western Madagascar contains a forest made of stone. Limestone's blades rise so densely that the landscape becomes a maze of needles, fissures, towers, and hidden cavities. Some pinnacles reach roughly 100 meters. From above, their gray edges flash among green vegetation like the roofline of an impossible metal city. The word Tsingy is often associated with the difficulty of moving across the sharp ground. In many areas, progress requires bridges, cables, ladders, or highly specialized routes. The apparent fortress is real in one practical sense. Its geometry restricts movement and creates isolated habitats. The formation began with thick limestone deposited in an ancient marine environment. Once exposed, and rainwater mixed with carbon dioxide and became weakly acidic. It entered fractures and dissolved the calcium carbonate. Over long periods, narrow cracks became deep grikes, while surviving blocks were sharpened into blades and pinnacles. Water operated both above and below ground. Caves, underground drainage, springs, and collapsed voids developed as the karst matured. Seasonal rainfall and vegetation influenced the chemistry, and the plateau's structure guided the direction of the emerging labyrinth. Tsingy de Bemaraha is also biologically extraordinary. Difficult terrain and Madagascar's long isolation created refuges where endemic species evolved. The same rock that blocks people can separate populations over surprisingly short distances. Nothing about the forest was assembled, yet it possesses corridors, walls, wells, chambers, and towers. Those architectural forms are consequences of subtraction. Acidic water removed rock along a network of weaknesses until the remaining limestone became sharper than many manufactured edges. At Zhangye, nature did not build upward, it dissolved downward, leaving a city-shaped remainder. Number 3. Wulingyuan, Hunan, China. More than 3,000 narrow quartz sandstone pillars rise through the forests of Wulingyuan. Many exceed 200 meters in height. Mist moves between them, separating each tower from the next and making the landscape appear like a vertical metropolis with no roads at ground level. The pillars became globally familiar through comparisons with imagined floating mountains, but their geology is firmly terrestrial. Thick sandstone beds were fractured by tectonic forces and uplift. Water penetrated the joints, streams cut valleys, and weathering attacked exposed surfaces. Softer material and weaker zones were removed, while more resistant columns survived. The rock is commonly called quartz sandstone because of its high quartz content, although real formations include layers, immense, and variations that influence how they erode. Vertical joints provided the initial layout. Erosion enlarged the spaces between them. Dense vegetation then occupied ledges and summits, strengthening the illusion of separate towers intentionally placed across the valley. covers about 26,400 hectares and also contains ravines, waterfalls, streams, natural bridges, caves, and calcite deposits. The pillars are therefore not isolated oddities. They are the dominant expression of an entire drainage and weathering system. Their continued survival is a balance. A pillar must resist erosion, but it also contains fractures that will eventually divide it. Rockfalls are not failures of the landscape. They are the process that maintains its vertical form. From the valley floor, the towers seem individual. Geologically, they are relatives, pieces of a once more continuous sandstone body. The city was not erected tower by tower. The streets were cut away around it. Number 2. Devil's Tower, Wyoming, United States. Devil's Tower rises 264 meters from its base and 386 meters above the Belle Fourche River. Its summit measures roughly 55 by 91 meters, close to the footprint of a large sports field. But the feature that makes it appear engineered is its surface. Immense polygonal columns run almost vertically from top to bottom. Some columns near the base measure approximately 1.8 to 2.4 meters across. They are among the largest examples of columnar jointing known. Their scale creates the impression that the tower was assembled from stone beams too massive for any crane. The rock is phonolite porphyry, an igneous material that formed from magma. As the body cooled and contracted, cracks divided it into columns. The broad physical principle is similar to Giant's Causeway, but the size, rock type, cooling environment, and exposed shape are different. Erosion then removed the surrounding sedimentary rocks and revealed the more resistant igneous body. The Belle Fourche River and weathering continue to excavate the landscape. Broken column fragments form a vast apron of talus around the base. One question remains genuinely debated: the precise form of the original intrusion. Geologists have proposed a volcanic neck, a laccolith, a shallow intrusive body, or other related models. The National Park Service presents multiple hypotheses because the ancient surface has been stripped away, removing evidence that might have distinguished among them. The site is also sacred to numerous indigenous nations, whose names and traditions carry meanings far older than its designation as America's first national monument in 1906. The geology should not erase that living cultural significance. Devil's Tower is understood well enough to reject artificial construction, yet incompletely enough to remain scientifically compelling. We know why the columns cracked. We do not know exactly what shape the magma body had before erosion unveiled it. Number 1. The Richat structure, Mauritania. Near Wadain in the Sahara, concentric rings spread across the Adrar Plateau until they form a target approximately 40 kilometers wide. It is larger than many cities. From the ground, the ridges can feel like ordinary rocky hills. From orbit, they lock together into one unmistakable eye. That difference in scale is the key to its mystery. Early interpretations considered an impact crater because circular structures often mark collisions. The idea was reasonable, but the expected evidence of a major meteorite impact was not found. There was no convincing pattern of shock metamorphism capable of explaining the whole feature. Researchers now interpret Richat as a deeply eroded geological dome associated with uplift above igneous activity. Sedimentary layers were raised and warped. Intrusive and volcanic rocks affected the center. Erosion then cut across the dome. Imagine pushing upward beneath a stack of differently colored and differently hardened sheets. The stack arches. Now slice horizontally through that arch. Each sheet appears at the surface as a ring. Resistant quartz-rich layers form ridges. Weaker beds retreat into lower ground. Differential erosion turns buried structure into visible geometry. This mechanism explains why the rings are not perfectly machined. Their spacing varies, ridges break, sand crosses them, and the eye is a geological cross-section expanded to continental scale. The Richat structure became a landmark for astronauts because its full pattern is so clear from above. That fact has encouraged claims connecting it to lost cities and Atlantis, but visual resemblance is not archaeological evidence. No verified urban remains, engineered ring walls, or destruction layer establishes that story. The formation's power comes from what the rocks actually demonstrate, not from attaching a civilization to them. Its visibility from orbit also reverses the usual logic of exploration. Most landmarks become clearer as you approach them. Richat becomes harder to understand. Drive across its outer ridges and the circular plan breaks into separate escarpments, dry channels, fields of loose stone, and long horizons. A person can cross part of the formation without ever seeing an eye. Only altitude joins the fragments into a single image. And that is why satellite observation has changed the way scientists and the public perceive landscapes. Remote sensing does not invent patterns. It reveals relationships too large for ground-level vision. River systems become branching networks. Dunes become waves. Faults become lines extending across provinces. At Richat, separate rock units become a bullseye. The center adds another layer of complexity. Igneous intrusions and hydrothermal alteration show that heat and fluids changed the rock from within, while surface erosion removed material from above. And the present shape is therefore not the product of one event. It is its intersection of sedimentation, uplift, magmatism, fracturing, chemical change, and prolonged denudation. Even with the broad model established, details of the igneous and hydrothermal history continue to be studied. Science has replaced one explanation with a stronger one without reducing the spectacle. Richat changes the way we think about artificial-looking landscapes because it reveals the limits of human perspective. Stand inside it, and the design disappears. Rise hundreds of kilometers above Earth and the planet displays a symbol no one drew. 15 different for nature to imitate intention. A tiled shore in Tasmania, limestone cones in Bohol, balanced granite in Zimbabwe, inhabited chimneys in Cappadocia, striped hills in China, accidental statues in Argentina, a frozen stone skyline on the Lena, Saharan arches in Chad, basalt paving in Northern Ireland, banded domes in Pernalulu, limestone blades in Madagascar, sandstone towers in Hunan, gigantic columns in Wyoming, a 40-kilometer eye in Mauritania. None requires an unknown builder, but none is ordinary. Straight lines can emerge from fractures, hexagons can emerge from cooling, repeated cones can emerge from shared material and climate. Towers can emerge when everything around them disappears. Rings can emerge when erosion cuts through a dome. The lesson is not that nature is secretly an architect. It is that simple physical rules, repeated across immense spans of time, can create order more convincing than design. Which formation looked most artificial to you? Share your choice in the comments and subscribe for the next journey into the places that make Earth look stranger than fiction.